didn't do well on the last quiz. Today is going to be about review. So we're going to go relatively quickly through all of these different operations to make sure that you understand what the rules are. Okay? And our first one, we're going to do adding of fractions. Normally adding is really easy, but adding in fractions is one of the more complex operations to do. Why? What is the first step? What is the most important thing I need to do in adding fractions? Let's say that. Good. So step one is find a common denominator. Now, even though we're saying a common denominator, we actually gave you really good tools in the last class for finding the lowest common denominator, and that is using the cake method with the two denominators to figure out where they meet first. So basically what we're saying is I can pull out my two denominators, 14 and 7. What number would go into both of them? 7 goes into both of those, a 2 and a 1. So if I multiply them all out, which is how I find my least common multiple, 7 times 2 is 14 times 1 is 14. So I know they'll both meet at 14. Meaning I don't have to do anything to the 10 because it's already there. How do I get from 7 to 14? Wesley? Multiply by 2. So anything I do to the bottom, I have to do to the top. So I can now rewrite this as 10 14ths plus 4 14ths. And then once I have the common denominator, what's the next step in adding fractions? Wesley? Just add the numerators. I don't do anything else to the denominator. It now stays the same. So 10 plus 4 is 14. I keep my denominator as it is. In our last step, my personal favorite, what do? Simplify it. So 14 over 14 becomes 1 whole. Oh, well, it just says first step.
This is use this. I wrote all of this.
Okay. So I'll write the other steps up here. So after we find the common denominator, then add the numerators. And finally, simplify. Any questions on any of those steps?
Hey, write it.
I wrote it, you write it. Ms. McShan made me write it. You got to write it too, Nate.
He did it the same one and it's repeating.
Oh.
But I took this other one, so he has to redo it.
Oh, yeah, sorry, you got to redo it then. Okay, we're going to give you guys about 3 minutes to do the next two. Okay, guys, this one should have been relatively easy.
Yep.
12 and 4. I divide both those by 4. It gets me a 3 and a 1. So 4 times 3 is 12, means I'm meeting at 12. 12's already there, so I just multiply this one by 3. That gives me 8 12ths. 1 times 3 is 3 12ths. Once my denominator is the same, I just multiply the numerators. 8 plus 3 is 11. Can't simplify that any, so 11 12ths. Okay? Our next one, 15 and 10. I can divide both those by 5, gives me a 3 and a 2. So 5 times 2 is 10, plus times 3 is 30. So I know that they will meet at 30. So I'm going to multiply this one by 2, multiply this one by 3, gives me 4 over 30, plus 6 over 30. Adding those together, 6 plus 4 is 10. I can divide both those by 10, simplify, gives me 1/3. If you didn't see the bigger numbers, you can always do 2, 3, 5, 7. Reduce it twice, you would still get down to the same number. Questions on any of those three? Okay? Oh, yes, Emily. The 5? Because 15 and 10 can both be divided by 5. So the greatest common factor is 5. The least common multiple, or the least common denominator, is 30. All the numbers on the outside. Okay? Okay, let's talk about adding mixed numbers. And we'll let Ms. McShan do this. See how excited she is to be out there. Guys, you have to be quiet though.
Is it on pause or is it recording? Recording. Great. All right, so what is our first step of adding mixed numbers?
Finding making it in a fraction.
That was my first step, but Mr. Moore does not like that step. He wants to separate the fraction and the whole numbers.
Oh, yes, it was. Mr. Moore just has a higher IQ.
No, actually it's just I try to make the math as easy for you guys as we can.
Until they get to multiplying and then they get confused.
They're going to get confused on that anyway.
And I know that because one of the students asked last time, well, can't I just separate them and then multiply?
That's all.
All right, so the first thing we're doing is separating the whole numbers. So 4 and 5 from the fractions, 3/14 and 2/7. Now what do I do? Wesley? Find the common denominator. So we do our cake method. We have 14 and we have 7. What can go into both of those numbers? 7. 7 goes into 14 twice, and 7 goes into 7 once. So 7 times 2 is? Times 1 is? 14. So 14 stays the same, so 3 stays the same. And for this one, what do I do to 7 to get to 14? By 2. So I have to multiply the top by 2 as well. And I get 4. Now I can add my fractions together. 3 plus 4 is?
Oh, it's 4?
7, and the denominator stays the same. Now what's my next step? I found the common denominator. I added my numerators.
Is it going to be 9 1/2?
Simplify. So what can I simplify 7 and 14 by?
2. Oh, wait.
7.
You could fit this.
And I get 1/2. Then what do I do?
Add the big numbers.
Add the whole numbers. And then last, I put them back together. All right, so 4 plus 5 is? 9. So I take my 9 and my 1/2, and my answer is 9 and 1/2. Any questions about how to do this?
Nope.
Yes?
That is
I'm sorry. Like watch on the problem part or the notes part? Okay, so did you see how I found the common denominator? And then that one stayed the same. 7 times 2 is 14, so 2 times 2 is 4. I added them together, and then I simplified it. I added my whole numbers, and then I put my whole number with my fractions together to make my answer. Make sense? All right, guys, the next two are yours. You have about 4 minutes, yes?
Yeah, that's what she put. And she's a genius.
What? Can you just multiply and then simplify?
No, I just do the no.
Make it improper? That's up to you. What is our first step for adding fractions? Or mixed numbers, sorry. Separate. I need my whole numbers in one place and my fractions in another place? I don't like talking
Yes.
over people.
No one should be talking but Mr. Chan right now.
All right, and then I come over here and I'm going to find my least common multiple out of 2 and 6. What can go into both of those numbers? 2. How many times will 2 go into 2? And how many times will 2 go into 6? So 2 times 1? And 2 times 3? 6. So my multiple is 6. So that's my denominator. This one didn't change. This one, what do I do to 2 to get to 6? By 3. So I have to do the same thing to the top number. And I get 3/6. Does everybody see that? So now I can add my fractions. 3/6 plus 5/6 would give me 8/6. What's wrong with that fraction? It's improper. My top number is bigger than my bottom number. So I have to fix that before I can go on. So I need to see how many times 6 will go into 8. How many times will 6 go into 8? Once, with 2 left over. So I end up with 1 and 2, 6. Can I simplify 2, 6?
Yes, you can make it into 1 3.
What can I simplify by?
3.
2. And I get 1 and 1/3. So now I come over here and I add my whole numbers. 11 plus 3 is 14. And I put that 14 with my 1 and 1/3, and I get 15 and 1/3. Make sense? All right, let's go over the last one. What's my first step? Separate my whole numbers from my fractions. So I have 3/12 and 3/4. I find my least common multiple. What can go into 12 and 4? How many times will 4 go into 12? And 4 is 4. So 4 times 3? 12 times 1? So this one stays the same, 3/12. This one, what do I do to get to 12? Times 3. So 3 times 3 is 9. So 3/12 plus 9/12 gives me 12/12, and that makes 1 whole. And then I add my whole numbers, 9 plus 7. So 16 plus 1 whole equals 17 wholes. Any questions? Why are you looking at me like I have 2 heads? Are we ready to move on? All right, let's look at subtracting fractions. What's the first thing we need to do? Yes? Find the common denominator.
God, he's a genius.
And what is that also called? How do we find the common denominator? We find the least common multiple. After we do that, what do we do? We did that. Then what do we do?
Subtract.
Then you subtract the numerators. And last, simplify. Any questions? All right, so let's start. I like writing mine as an actual subtraction problem. If you don't like that, that's fine. And then I take my 2 denominators and I find the least common multiple. What can go into both? 1. 1 goes into 14 times, and 1 goes into 9 9 times. So 1 times 14 is? And 14 times 9 is? Let's find out. 9 times 4?
36.
Carry my 3. 9 times 1?
9.
Plus 3?
12.
So I get 126 as my denominator. Now, we just worked out the problem that says 14 times 9, right? So, think about that. 14 times what gives me 126? Thank you. So 10 times 9 is? And 9 times what gives me 126? 14. Good job. So 3 times 14? So now I'm subtracting 90 minus 42, and what do I get? 48 over 126. Can I simplify?
Yes.
Yes, both of them are
Even.
even, so I know I can simplify by 2, and I get 24 over 63. Can I simplify? By?
Actually, you cannot. Actually,
By?
wait, you put 48 instead of 42.
That's because I did 90 minus 42 is 48.
Is it 3?
By 3. And I get 8 over 21. Any questions about subtracting fractions? It's the same as adding, just now we're taking away instead of adding to it. All right, 4 minutes to do the next 2 problems, and then we'll go over them. All right, guys, pay attention. 5. All right, so we start with our fractions. And we need to find the common denominator, so we do our LCM. What can go into 14 and 4?
Guys, talking stops now.
How many times will 2 go into 14?
7.
How many times will 2 go into 4? So now we multiply all the numbers on the outside. 2 times 7? 14 times 2? 28. So our common denominator is 28. What do I do to 14 to get to 28?
Multiply by 2.
By 2. So 6 times 2 is 12. What do I do to 4 to get to 28?
Multiply by 7.
So 1 times 7. And now I can subtract. 12 minus 7 is 5/28. Can I simplify that? No. That is my answer. All right, let's go over the last one. I separate my fractions. My denominators are 12 and 5. What can I simplify by? What can go into both? 1. So 1 goes into 12 times, and 1 into 5 times. Guys, I do not like talking over people, and you can't learn when you're talking to others. Please listen. 1 times 12. 12 times 5. 60. So 60 is my common denominator. What do I do to 12 to get to 60? So 8 times 5. And what do I do to 5 to get to 60? So 2 times 12. And now I can subtract. 40/60ths minus 24/60ths. 16/60ths. Can I simplify? By what? 4. And I get 4/15. If you simplified by 2, that works as well. You'll just have to simplify by 2 again. Any questions about that? All right, Mr. Moore.
This one gets a little more complex. So we're basically just going to go over the rule. Then we come back from lunch. We'll actually start working the problem. When I am subtracting mixed numbers, the first part is going to be the same as what we were doing before. I'm going to pull the fractions out. Okay? So first, pull out the fractions. And find a common denominator. Okay? Now here's where this one gets a little more tricky. If my first numerator is smaller than my second numerator, I have to borrow from the whole number. Okay? So 2, and this is an if. This isn't going to happen every time. If the first numerator is smaller than the second. Okay, we'll finish up after lunch, guys. Okay, now that everybody's back, make sure you wrote down the rest of what I had done. So the second rule, if the first numerator is smaller than the second, you're going to borrow from the whole number. Now here's why this gets a little bit tricky. So let's take a quick side step. I am borrowing one whole and I am making it a fraction, correct?
Guys, what you guys written at the top needs to be on your paper.
Everybody okay with this? I'm borrowing one whole. I'm borrowing from the whole number, correct? But I'm now making it a fraction, aren't I? Here's what gets really cool. If I have a fraction, which we've often represented as a circle, right? How can I divide that fraction up? Could I make it into halves? Could I do a one whole and make it a half?
Yes.
How many halves would I have?
4. I mean, 2.
I even drew a picture for you, JJ. There are 2 halves in my picture, correct?
Yeah.
So it'd be 2 over 2, right?
Yes.
What if I borrowed fourths? How many fourths would I have?
4.
4 fourths. Are you seeing a pattern? What if I borrowed 8? How many eighths would I have?
8.
8 eighths. So I can borrow whatever amount I want to, can't I? Okay? So quick side step back to the rule we just did. If I'm adding fractions, in other words, I borrowed from this whole number, I'm now adding it to the fraction piece. What's the key to adding fractions? What do I have to have? Common denominator. So when I borrowed my one whole, how much am I going to borrow? Whatever my denominator is, right? Does that make sense? So really, when I borrow from the one whole, all I'm going to do is add the numerator and denominator together for my new numerator.
So what I'm just showing you that a whole can be divided into any amount of pieces.
So I'm making a new numerator because I have to have it bigger than my second numerator. Okay? So yes, that picture was just to show you that I can divide that whole that I borrowed into whatever I want to. Okay? Now we're going to subtract the fractions. Subtract the numerators, not the denominators. Then subtract the whole numbers. And finally, if needed, my personal favorite, simplify it. So I'll read it all again because there's a lot up there.
It's actually
Yeah, subtract.
You have
I gotta make sure you wrote it right.
Subtract the whole.
Yeah, you did.
Okay.
wait,
So you are adding the numerator and denominator once I borrow. That's only adding you're doing it here. So first, pull out the fractions, find a common denominator. You got to do that part first. Then, if my second numerator is larger than my first, I have to borrow from the whole number. So I'm going to cross out the whole number, drop it by 1. But normally when you do that, you're borrowing 10 because I'm moving my places of 10, but I'm now moving to the fraction slot. Meaning I can make it whatever fraction I want. So whatever that denominator was I found is my common denominator. That's how much I am borrowing. So for my new numerator, I'm just going to add my numerator and denominator. That's going to be my new numerator. And then subtract the fractions, subtract the whole numbers, and simplify. So what does that look like in practice? Well, let's take a look. Here I've got 14 and 7. So my common denominator is, divide 7, 2 and 1, it's going to be 14. So I don't have to do anything here. I am going to rewrite this, because I really like the way Mr. Shannon did this part. One of the big advantages you guys have to having 2 different math teachers. We both bring different ideas. So my common denominator is 14, so I'm going to have to multiply this by 2. So that makes this now 4 14ths. Can I take 3 and subtract 4? No, I can't do that. Okay? So I have to borrow from the 6. I make this a 5. My common denominator was 14. So how much am I borrowing from that one whole? 14 14ths. So technically what I'm doing is adding 14 14ths. The easy way to do it, what I put up here is I just add my numerator and denominator. 3 plus 14 is 17 14ths. Now I can subtract. 17 minus 4 gives me 13 14ths, because I don't do anything in my denominator. 5 minus 3 is 2. 13 over 14. Can I simplify that at all? Nope, so that's my final answer. Yes, Danny.
still, why do you add it? I don't get it.
Just like whatever you're borrowing on your regular.
Okay, watch this.
With the other one.
What if I did 20 minus 8? How do I subtract it? Can I do 0 minus 8? No, so what do I have to do? I borrow from the 2, I make this a 10. What did I do? Technically, I just added 10 to those 0 ones, right?
Because you took 1 out of the 10's place and gave it to the 1's place.
I did the same thing here, but I didn't take 10, I only took 1. But now because I'm in the fraction piece to where I borrowed to, I can make that fraction whatever I want to. I'm working with 14s. My fraction rule, to add fractions, I have to have the same denominator, right? So when I borrowed that 1 I borrowed here, I made 14 over 14 so that I could add it.
So you'll never learn to do it with place value? Where you're taking, like, the 2 is in the 10's place, right? The 2 is in the 10's place, right?
Oh, yeah. I keep thinking that's.
So if you cross out the 0 and you give this, you took 10 away from the 10's place, basically. You changed it from 20 to 10. And you give 10 to that 0, it becomes 10. Make sense? So if I had 21 minus 8, you take 1 away from the 10's place, you give it to that 1, so it becomes 11. Because 10's place gives 10 to the 1's place.
Wait, why should we keep 21 again?
So I could show you with another number other than 0.
Okay.
Make sense?
Yeah.
Okay? Is everybody clear on subtracting the mixed numbers? Okay, we'll give you guys 5 minutes. Work on the next 2.
All right, guys. Let's go over these. 5, 4. All right, so you start by writing it as a regular subtraction problem. And then we find our common denominator between 2 and 8. What can go into both of those? 2. 2 goes into 2 1 time, and 2 goes into 8 4 times. So 2 times 1 is 2. 2 times 4 is
8.
8. So my common denominator is now 8. So this one's going to stay the same. What do I do to 2 to get to 8? So 1 times 4 is 4. So can I do 4 eighths minus 6 eighths?
No.
No. So I need to borrow from my whole number. It becomes 8. Now I'm giving that one whole that I just took away to these 4 eighths. But this is a fraction. So how do I represent one whole as a fraction when I'm talking about eighths?
Make it in progress.
8 over 8.
Lots of parts.
So I'm giving these 4 eighths and 8 eighths and putting them together. So how much do I have now? 12 eighths minus 6 eighths is what? 6 eighths. Can I simplify that?
Yes.
By what?
2.
2, and I get 3 fourths. 8 minus 3? 5. So my answer is 5 and 3 fourths. Any questions? I was trying to get out of your way and I forgot that chair was there. All right, the next one. 11 and 6 twelfths minus 7 and 1 fourth. I need to find a common denominator between 12 and 4. What can go into both? 4. 4 goes into 12 3 times. 4 goes into 4 1 time. 4 times 3 times 1. So this one stays the same. What do I do to 4 to get to 12?
Times 3.
And 1 times 3? 3. Can I do 6 minus 3? Yes, I get 3 twelfths. Can I simplify that?
Yes.
By? And I get 1 fourth. Then 11 minus 7?
4.
So my answer is 4 and 1 fourth. Any questions? All right, let's move on to multiplying. This is probably the easiest form of fractions we will do. What is our rule when we are multiplying fractions? What do we do first? Avi? Do I need a common denominator when I'm multiplying fractions?
No.
No. So what do we do first? Thank you, Nora. We multiply numerator times numerator. After we multiply our numerators, what do we do? Yes, multiply the denominators. And then what do we do? Simplify.
Simplify.
You are very lucky I'm on recording right now. All right. I'm going to do this for you 2 different ways because I have a way I like to do it. Mr. Moore has a way he likes to do it. And we have noticed that all of you choose different ones. So some of y'all choose my way, some of y'all choose his way. So I'm going to do it both ways. Of course, I'm starting with mine. So 2 times 6 is 12. 10 times 7?
17.
Can I simplify?
Yes.
5?
2.
2, and I get 6 over 35. Can I simplify that?
Yes.
By?
3. Sorry.
Not 3. Not 5. Not 2. That's not even.
Nothing.
Nothing. 6 over 35 is my simplified answer. Now, Mr. Moore's way, he likes to work with smaller numbers, and I am talking over lots of people. But you have to remember to use the X pattern. You cannot simplify 2 denominators. You can only simplify them if they are across from each other in an X pattern. One numerator, one denominator. Can I simplify 2 and 7? No. Can I simplify 10 and 6?
Yes.
By what? 2. So if I divide 6 by 2, what do I get?
3.
And if I divide 10 by 2, what do I get? 5. So now I have 2/5 times 3/7. Smaller numbers. 2 times 3 is?
6.
5 times 7?
35.
You get the same answer no matter which way you choose. It just depends if you want to simplify first or after. Got it? All right, I'm giving you 2 minutes to do the next 2. Almost time, yeah.
Yeah, you are sorry. I'm sorry.
I don't know what I'm like. I'll fix my mom.